Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and a very good day to you. So welcome back to our class discussion. So today we're going to continue our discussion to our chapter 6. So chapter 6 is data analysis. So means that we will discuss, I will share with you about all the spatial analysis that can be done using GIS software. So some of this analysis we will do later on in our lab exercise. So chapter 6 is data analysis. So spatial data analysis. So this is the content of this topic. So the first one we will make some introduction, and then we will go to the first analysis in GIS, which is the measurement. So we can measure the length, the perimeter, and also the area, and then we will do the queries. The second analysis is queries. So queries, we will ask both of the attribute analysis and also the spatial analysis. And then we will also see the classification, how we classify our data. And then after that, we will see buffering and neighborhood functions. So we will see how to make some buffer, the radius from certain object that we selected. And then we will see the map overlay. So we will integrate, or we will overlay between 2 or 3 layers, and then we get the another layers maybe. So this one we will see a little bit on the vector analysis and also the raster analysis. And then we will see the spatial interpolation, so how we interpolate the area that without data from the certain data that we collected. And then the next one is the surface analysis, and then lastly is the network analysis before we conclude our discussion. Alright, so we move into our first part, which is the introduction. Okay, before that, there's some question to ponder. Okay, what data analysis operation are available in GIS? So I already list some of it previously in our content. And then how are feature measured in GIS? So this will be answered using the first analysis, which is the measurement. And then how are spatial and attribute data queried in GIS? And then the next question is how are network analyzed in GIS? And then also how are surface being analyzed in GIS? How we show the surface area in GIS? Then how we make an analysis, what type of analysis of surface analysis can be done in GIS? And then what are the differences between analysis carried out on the raster and the vector data? So we have two type of spatial data, which is raster and vector. How we differentiate between this type of data? Okay, and then what are the problem faces when conducting data analysis in GIS? So this is some question to ponder throughout this topic. Okay, so this is some of the example in spatial analysis in GIS. So over here we can see the buffer analysis. They have four type of buffering from the main data sources. Okay, over here we can see we can overlay between 5 layers of data will become a new layer, or maybe some analysis from there. We can see what's the most suitable area for that surrounding or for the certain analysis that we want. And then we can also make some probability analysis. We can see what the hotspot can be done. Right, some example. Okay, we will see later on how to do some of this analysis, or maybe all of it. Okay, some introduction. So we already see the data, GIS data, and then all this data have become an information to us. And then from this information, we will make some decision based on what the data, the information. And then to make the decision, all this decision related to GIS, we will need some analysis. So that's why this chapter will introduce the range of data analysis available, and then how to apply this analysis. So in GIS, many techniques can be used, such as measurement, attribute queries, proximity analysis, overlay operation, surface analysis, and network analysis. So in this topic, we will just discuss on surface, not really deep, because you will take some another subject which is spatial analysis. We will in that subject you will discuss further on the analysis. Okay, so we go to the first analysis in GIS, which is the measurement in GIS. So we will see how they do the three measurement, which is length, perimeter, and area in GIS. So basically, in GIS, how they do the measurement is using theorem Pythagoras. So that's the basic thing. So this is the formula. So we have the length of A and B, and then you can get the length of C, and then the combination of another formula for area, half plus this area A plus B, you get the area. So this is how they do the analysis for measurement. Okay. So length, perimeter, and area are common application. So we already discussed this a little bit. So measurement in GIS is an approximation based on the formula calculation. So means that it's based on the what data that we have. So it's not it can be accurate based on how accurate your data, the accuracy of your data. So as I said, it's based on the Pythagoras theory. Okay, so distance using Pythagoras theorem, the Euclidean distance, parameter, sum of straight line length. So from the distance we sum out all this all the line, so we can get the distance from here. Okay, for the example, this distance from A to B we can get from the equation previously. So 4 plus 9, and then do some calculations, square root for plus 9, and then we get 3.605 kilometer for A to B. And then for the perimeter, A to B, and then combine with added to the 3 kilometer and also 2 kilometer. That's how the perimeter. The area, the total area of simple geometric. So we can use the calculation from the mathematical calculation. So that's a simple measurement in GIS. Okay, so this example, so the measurement. Okay, the area is you combine, you can get area from 1 2 3 4, 1 2 3 4 3 4. So from there they can combine, and then they can get what the unit is. So for example, maybe 10 kilometers square. So this is some example lah, how they do the analysis for measurement. So for vector, maybe more simpler because we're using the theorem Pythagoras. So if you know on surveying part, the field survey, you can get the angle and distance, you can get the x and y, the coordinate, and then from coordinate you can convert into angle, degree, and also the distance. You can get some information from there. Okay, so you can get, and the x-axis you can get the input feature, and near feature you can get the distance, or distance from this point to the closest polygon, or the closest line, or the closest polygon, the touch area. Okay, and then you can get, if you have multiple point, you can get the distance also. So this is the basic for measurement, or for length measurement. So for raster, we will base on the number of cell sites. Okay, the area, number of cell in the area, and depend on the raster grade, as I said, based on the resolution or the grid, the accuracy. So if you see here, so this is the point, the area for this area based on the how much the pixel have been calculated inside there. The same goes over here. All right. So that's the first analysis, which is the measurement. So we can measure distance, perimeter, and also the area of the feature inside GIS in vector and also in raster. So secondly, we will see the queries. So query basically is how we ask the data or the system to give us information about certain query. So it provide data retrieval. So example, we can search for hotels or restaurant or houses. This is the some example in that we always use in Google, using Google Map or using Waze application. We want to find a new restaurant and so on. So query allow extension function, so booking room in hotel, etc. So this is example, as I said previously, in Google Map we can ask the near, maybe around 2 we want to find 2 hotel in 2 kilometer from our current location. So this is some queries lah. So query in GIS have two types. So the first one is non-spatial, means the attribute only. So secondly, we can ask with the spatial element, so based on spatial entity. So the first one is about the feature, how many budget hotel, how many two-story house, how many residential area, how many commercial area, how many factory in this area. So it's not didn't have any spatial component. So if you combine with the spatial element, we can ask how many hotel, for example 200 meters from Bangi LRT station or from UTM. We want to find what the nearest restaurant near, maybe around 2 kilometer from UTM. So it will have some spatial element over there. So query also allow both spatial and non-spatial query. So we can combine both question, how many houses in 1 kilometer from LRT station and have 3 bedroom. So this one is the spatial part. Spatial, do you have spatial element 1 kilometer, and then second one is only have the attribute information. So we can see over here the query in JS support this kind of analysis. Okay, so that's the simple, not really simple, we will do later on these queries inside our lab exercise, hopefully. Okay, that's the second analysis that can be done in GIS. So the third one is reclassification, mean we have certain value for our data, for our feature, and then we want to reclassify it into the certain other class or category. Right. So reclassification usually used for raster data. For example, where is oil pump area. So using image reclassification, we only have, for example, we have satellite data. Okay, this satellite data consists of so many pixel. So we want to reclassify all these pixel, and we want to see only see the oil pump area. So we give the oil pump area value 1, then other than that we just give value 0. So we'll give you 0 and 1. So we will see where's the oil pump area and non oil pump area. So other classification, classify for more than 5 category. Okay, this is example. So they have, maybe we have 3 to 4 satellite data, and then we give some value for this each pixel. Okay, for this one layer give 67 for the pixel value, and then 54 for the second layer, and then 21 for the third layer, and then 37 for the fourth layer. And then we classify over here, we compare with when we go to the field, we get the actual data on the field, and then we compare with this data, and then we classify back our all this data into one main classification. Or so over here we will have 1, 2, 3 classification only. Okay, so you can see R, F, U only. So urban, U is for urban area, F is for forest, and also U for the R for the river area. So we can see river over here go flow over there. Alright. So this is example. If you do some classification, the classification we combine so many type of layer of data, and then you reclassify back, and then you can get some data that you want to classify. For example, alfalfa, bear, corn, forage, peanut and legume, pasture, tree, urban, water and wheat. So from C we can see that the most majority area is pasture maybe, and also wheat. Okay, you can see green and also yellow most of the data. Okay, that's a reclassification. So we already discussed 4 for analysis. The next one is buffering and neighborhood function. Buffering is when we want to see what the other feature that is in certain radius from our main feature. So it's create the zone of interest around the entities. So what entities that we want selected. So they also filtering for raster data. For example, how many hotel within 200 meters from stadium. So how to do it is using buffer and overlay. Overlay later on we discuss. So can be different between point, line and polygon. Okay, so this is example of simple buffer of point. So if you only have one point, they will buffer from that area, and then if you have 2 point, they will have some overlay over here. Okay, they combine the area. So same goes to line. So this segment, okay, maybe around to 20 or 30 meter from the main line. So you can do the buffer analysis. So this is the example of buffer analysis for line, and for polygon they will based on the perimeter of the polygon. Okay, they will have some buffer. Okay, this is some example lah for buffering for point, line and polygon. Alright, for road they will do the buffering along the road, as I previously show, like this, along the road. For polygon, around the polygon. Okay, so for example, to identify land use, population total and conservation status for the active or nuclear area. So buffer can combine with other layer, not only one area. So this is example. This one is if using what you call it, the raster data. So they based on the pixel. So we can see this is the first buffer, and then the second buffer and the third buffer. Okay, okay, you can also see over here they can combine between this point, buffering of this point and point. So the name is nearest neighborhood. So some of the technique for buffering. So for raster is using filtering process. Like I said, this one is for raster. For vector is simpler. Just make a new polygon around the polygon, around the feature that we want. Okay, make some polygon around what polygon we're going to do. And then, but for raster they will give you the value for each raster pixel around the vector that we selected. Alright, hopefully you understand on the buffering. So the next one is the map overlay. How we going to overlay? For example, we have over here 1 2 3 4 5. So we have 5 layers from our real world. We can select and we can we can divide it into 5 main layer. For example, land usage, elevation, parcel, street and customer. But then this data represent only one area, so we need to overlay this data to see the whole scenario of this area. So map and overlay is ability to integrate 2 or more layer of map in GIS analysis. So it will create near layer of spatial data. Okay, basically the history is from map overlay 1969. So overlay will give us the visual comparison. So it involves managing data from 2 or more point of spatial data layer. Okay, so this is example of map overlay. So the upper one is using vector data, and the lower one is using raster overlay. So if we see here, the same data, one in vector, one in raster. So raster will based on the pixel. So if you have a high resolution, you will get the higher accuracy. So we have two values, 0 and 2 over here, 0 and 2. And then when we combine with another layer, which have 0 and 3, 0 and 3, the value of this data, it will give you 0, 3. This one is 2 because this area 2, and then this area is overlay with this area. So we combine and we give you new value, which is 5. Same goes in raster, but they're using the pixel value based on pixel. So this area of number 3, this is area of number 2, okay, number 2, and then this area is combination of area of number 3 and also number 2, so we give you value of number 5. Okay, so for map overlay, not only in raster and vector, we can do some analysis of overlay from point to polygon, line in polygon, or polygon in polygon. So this is the three type of vector overlay. So point in polygon, sorry, we will find point that fall in a polygon. For example, the school in Taman University, or the residential in or the house in Taman University near UTM. Or line in polygon, you want to see how many river is inside certain watershed, or in Johor Bahru district, or in Malaysia. So we can do some line in polygon example analysis. And then polygon in polygon, we can combine 2 or more polygon. Right, so we see over here, so the first one is point in polygon. So we have 3 point, 1, 2, 3. For example, this one is a meteorology station, and then we have a polygon of forest and non-forest area. Okay, and when we overlap these two map, it will give this type of new feature. Okay, they will also have an attribute. So number 1 is in forest area, second, number 2 is in forest area, number 3 is non-forest. So we can give you this type of data. So we give you data. So this is the below one is the example of line in polygon. We have road number 1 segment, 2 segment, 3 segment, 1, 2, 3 segment. So when we overlay with the forest area, it will give you another data. We create another segment, 1 segment, 2, 3, 4, and 5. So we become 5 segments. So number 1 and 3 in forest area, number 1 and 3, and then number 2, 4, and 5 is the non-forest area. So this is example of line in polygon overlay. So if for map overlay polygon in polygon, for example, over here we have for polygon in polygon, they will give different result. For example, we have forest in polygon area and also the resort area. If we combine and using the union analysis, means we overlay and selected union or okay, they will give you all the data. They just show you all the data, and then this is the forest resort area. Sorry, this one is the forest area. Okay, if you combine these two data and you selected erase, it means that all data that not included will be erased. So we give you this is the resort area and only the forest area only. Okay, if you combine forest and also the resort and you selected N, means that only a forest in the resort area, they will give you this area only. Okay, so this is some example of polygon in polygon overlay. Okay, for raster, it will show and analyze in cell or based on pixel. So it will give will be based on the mathematical equation, based on added, subtracted, multiplied, divided. So it will affected by resolution and scale of measurement. So for example, if you want to define the data, you need to reclassify back first. So we have 0 and 1. We multiply by 3, so we can get 0 and 3. Why 3? Because we want to get later on this data. Okay, this reclassification. So for another data, 0 and 1, just multiply into 2. So we get data of 0 and 2. So the upper one is 0 and 3. If we just use 0 and 1 and 0 and 1, it will not justify the final product. So we need to reclassify first, and then before we overlay between these data. So we can see here, this area is from this map 2. This area have become 3, and then over here 3. But this area, this small area, is 2 plus 3. So multiply first, reclassification, and then we added these two data, or we can subtract, or we can divide it. based on what formula that you want to use. So this is the map overlay for raster. Little bit easier than vector, because vector will have we need to have a complex computer programming. So this is another example. We have cover type and also slope classes. We have three class over here, and then three class also. And then if you intersect, you can use added value, and then we give you this map, this final map lah. So we give you the highest area is the green one. Okay, so that is the map overlay. So the next one is the spatial interpolation. So spatial interpolation is the analysis where we estimate the value of property at unsampled site. Means that this certain area, for example this area don't have any data, so we going to create a certain value for this area based on the other value that we collected over here. So that is some explanation lah. So we only have certain data for certain area, and then we interpolate data for the other area that don't have data. So the role of interpolation to fill the gaps between observed data using sample data. So usually for height contour, but sometimes we use for another data lah. Okay, for example we have meteorological sampling, or maybe for haze we have certain point, the station point, and then from there we interpolate. We can see which area is maybe affected or maybe not affected based on the data we get. Okay, I will show you how to do it later on. So the problem is this data is inaccurate because we just make assumption. So for example the slope, and then we also have some problem of human error, subjectivity, and then amount of time for interpolation. For example, using LiDAR data. Okay, this is the technique for spatial interpolation. They have three main technique: Theissen polygon, triangulated irregular network, thin, and also spatial moving average. So the first spatial interpolation is the Theissen polygon, so also known as a Voronoi polygon. So it assumes that the value of unsampled location are equal to the value of nearest sample point. So created by subdividing line joining nearest neighbor point, and also draw perpendicular bisector through this line, and then using this bisector to assemble polygon edges. So this is the example. So they have for example F, A, B, C, D, E. So they have the data, and then they can interpolate to get the data based from this data to get the data inside there, the zero area. Oh, okay, from there they can combine to get this the height of this area. Okay, they have point A, F, A, B, C, D, E. So from the Voronoi they make some line or calculation, and then from there we can get, for example this one is 0, this one is 10. So we make some assumption the height over there. So maybe this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like that. So this is the Theissen polygon. Okay, so for example P2, P3, P4 they have example, another example, for example maybe the rain calculation or rain measurement. Okay, and then from there interpolate the data between this point, and also this point, and this point. So using the Theissen polygon method. So the second one is the triangulated irregular network. So if you see here, they have triangulate. So they have the first thing is means that they need to have 3 points, and then they will form a triangle from there to make surface, to make the area. So from there they have, for example, over here we have 1 2 3 4 5 6 7 point, and then they interpolate and they give a value for this unknown point. So that's the meaning of interpolation. Okay, from there, for example, we have certain area and then we interpolate and then give you data. So this is example. So this is the point that we collected. It's not regular, not in one in the line, straight line and so on. It's just irregular point. And then they will interpolate from the height. They will combine between these 3 points, and then they will interpolate based on the height of this point, interpolate which is the most high area, and then we will give the height like this. So they will give you a view of this surface area. So this point connected, so they assume this is the slope like this, okay. So that's why we call it the assumption or interpolation. We interpolate data based on the unknown area from the known data. So that is a theme. The last one is spatial moving coverage, spatial moving average. They calculate value of location based on the range of value attached to neighboring point that fall within user defined range. Okay, this is mostly used for raster data. So from there we calculate the raw data, combine, and then we'll give uh, the value into the unknown data. Same goes over there, but only the calculation inside the inside behind the software. So that's the interpolation part. Okay, the next analysis is a surface analysis. Surface analysis means that we're going to do some analysis from the surface area. For the surface area, we want to see maybe what we can see from this height. Okay, there's some example what is the slope of this area. Okay, so surface analysis is two-dimensional topological manifold. So based on the spectral interpolation method, so we already know what is interpolation. So method in surface analysis, we have at least 4. We have the first one is slope, second one is aspect, the third one is Hillshading, the last one is visibility analysis. We also have so many others analysis, but what we're going to cover in this topic is only these 4 lah. So the first one is slope analysis. Okay, it will give you the gradient of terrain measured as angle in degrees. So that's the basic thing lah. Okay, so this example, if into the view we can only see like this. Okay, we don't know. Okay, we know this area is high, this one is the lower area. In 3D view we will see like this, but we don't know how steep is this area. So this slope analysis, slope map, will give us the terrain steepness. How steep is this area? Okay, from this is not steep area. So from here we can see, okay, this is maybe we'll have more risk for maybe landslide. Okay, this one is lower risk. So from the slope map we can see which area is in the steepest area is not, and also the not steep area. Okay, the second one is the aspect. So aspect analysis is the compass direction in which a slope face. Means that certain area where it faces. Is it north, south, or east or west, or maybe others? Okay, so from north is usually expressed clockwise from 0 to 360 degrees. Okay, for example over here. Okay, this is north. So north means is the red area. So the red area is facing north over there, facing up over there. North, south is the cyan color. So this one is south. So this is the south area, southeast, and then southwest, and so on. Okay, sorry. Okay, so means that if this is maybe the highest area, because this area is west area, this one is the east area. So maybe this is the highest or flat area. Okay, the highest or maybe the lowest. No, the lowest. I think this is the highest area lah. So and then they fall over here. Okay, so this is the aspect analysis, simple one, not very detailed in this topic, in this subject. Okay, the third one is hillshading. Hillshading is cartographically called shade relief. It's a lighting effect with miming the sun to highlight hill and valley. Okay, if we see here, so means that hillshading means that this area is receive sun, uh, light from the sun. This one is not receive a light from the sun. So for example, maybe this is some volcano, maybe. Okay, the not receive area, and then over here also receive, so means that there's something over here, maybe some lake, I don't know. So from here they also can see, okay, this is maybe a lake, the white one. Okay, because this is should not be like this. So this is area with for example, what the usage of this analysis. For example, if you want to put the solar panel, so you want to see which area is get more highest concentration of sunlight in the morning or in the afternoon, so you can do some analysis from here. Okay, and then the last analysis for surface analysis is the visibility analysis. So visibility analysis is what is visible from a certain location, or where from location can a specific area be seen. For example, we put ourselves over here. So this area we can see, this area we can see, we also see, this area we can see, but this area we cannot see. So maybe around this area also cannot see. Okay, so this is example. We put certain maybe camera CCTV, we put over here, and then we can see what the obstacle from this area. Is it suitable to put CCTV over here, or we need to adjust it? Okay, so that's the usage of the visibility analysis for surface analysis. So for example, we see over here in top of the mountain, the green area, usually using green is the visibility, we can see this area, but the red one we cannot see. Okay, so there's some example of the visibility analysis. So finish on the surface analysis. So the next one is the network analysis. So network analysis, a network set of interconnect line making up a set of features through which resource can flow. So means that we have so many line, and then this interconnected, they have connected between each other, and then we can see which the area or which the flow of that certain line. So this type of network analysis: shortest path, traveling salesperson problem, allocation modeling, and route tracing. So this is example of network analysis that we currently use in Google Map or Waze. It will give you the road that connected, which road can connect from A to B, from this hospital to another hospital. For example, we have incident over here, which the shortest hospital, the shortest route we can arrive to a hospital. Okay, so but we need to have interconnected line. So if not connected, we can, for example, this man, when this man not connected directly, so we can use this man to connect with this man between these two. So shortest path means that we're going to find the most short distance lah. You know, for example, the more easier word. So the shortest path between one point and another point on a network based on the shortest distance. So evaluate the link and turn required to traverse a network between stop. Then several potential paths may be considered. So select route with least cumulative impedance, and then repeated until whole journey path is defined. So based on data model, raster or vector. So for raster, using proximity analysis, can add cell value such as cost or tolls and so on. So vector, more flexible, can add pendiment, also traffic and congestion that we currently use in Google Map or Waze. So this is the example. Okay, from 0 we gone to 7, you find 0 to to 4. Okay, and then is it connected between each other? Is it the flow is both way or only one way? So we will see. It will show us what the shortest route. Okay, for example, from 0 to 6, so you need to travel over here, over here, over here, over here, or maybe from over here, over here, over here, over here, over here. So you cannot directly to 6 because the flow is not directly flow from 0 to 6, only from 6 to 0. So that is some example. So for raster, we connected between pixel to pixel. Okay, so we give you A to B. Maybe can cross from over here to here, not over here to here. So, but usually people don't use the raster lah. People use vector for network analysis, shortest path. So the second analysis in network is traveling salesperson problem. So the name will based on one salesman need to visit a specific set of client and to do so by the best route option. So usually this type of network analysis is using by postman or post office. So we're going to reduce the number of they want to maximize the number of stop for in the shortest time lah. For example, waste collection vehicle, collect garbage and return to the base, and then deliver man need to stop at 10 places. So they calculate minimum path between each stop and every other stop. Okay, so it's not the shortest path, but we cover what the highest area or highest stop that we cover in the shortest time. Okay, or the optimum number. So for example, we have 4 different paths. So the first one is path length is 69, path length is 66, path length is 57, and then path length is 86. So the most optimum is maybe is the number 3 over here. Okay, 7 to 6 to 3 4 8 or 4 5 9 8 2 1 0. Okay, this is no sorry, the path is 0 1 2 8 9 5 4 3 6 7. Okay, not like this. This is not very optimum because the path length is 69. So you can see also beside postman, we also can see if the utility such as electric or water bill, we want to go to each houses. So for the residential housing area is not a problem, but in, for example, in the village area, the house between house and house is quite far, so you need to have some problem, some analysis like this. So the name of analysis is traveling salesperson problem. Okay, so this is the question. Okay, just selling using eBay or currently using Shopee or Lazada or whatever, Amazon, but still the postman need to do the calculation lah. So the third one is a location allocation modeling. So modeling supply and demand to allocate the resource and mesh between demand and supply. So require the movement of goods, item, people, information or service through network. Allocate link supply center. So this analysis can determine the maximum catchment area of particular supply center. For example, to identify the optimum location for new center to service a shortfall in supply relative to demand. If current school cannot supply the demand, new school is needed. So for example, over here, so this is one of your senior, not senior lah, your colleague taking this program, Master of Science Informatics, Mr. Kin Chen currently doing analysis on this. He want to see the house, the school area, is it compatible with the residential area? Is it okay or not okay? So using the allocation modeling. Okay, you can see from there For example, the current situation is we have so many uh, post uh, post company, uh, post postage agency, whatever lah name. For example, in JNT, and so previously don't have any center in Skudai. So currently, in last 2 or 3 months, they create a uh, new office in Taman University near UTM to support this center, because they can have a new center for supply and demand. So this another location allocation modeling using network analysis. Okay, so this one is 8-minute response, 11-minute response, and 15-minute response. So this is the most concentrated area response, maybe for firemen or hospital and so on. Okay, and then other in 11 minute, and then the 15 minute, and then other than that is out of reach, maybe. Okay, so from this analysis we can, maybe we need to have another hospital over here, and over here, this area. Okay, not only concentrated on this area. So maybe we can create a new based on this analysis, we can create a new hospital or fire office and so on, fireman office. Okay, last one is route tracing. So tracing is trace flow of good item, people, service, or information. We trace back, will based on flow direction. So determine the stream, contributing reservoir. So find all water or house affected by with water disruption and so on. So this is what we call route tracing. So maybe we have some data. Then if we stop over here, what will happen? Okay, if this line of water stop, we close over here, which area housing is affected by our decision to close this road or this water pipe. Okay, so this is example of road tracing. We can trace back where we go. So this also another example. So lastly, we will discuss analytical modeling and GIS. So analytical modeling is a process simulate a real world process. Summary of process model can be based on conceptual model, and then will give more alternative based on analysis. Means that for analytical modeling means that we can combine all the analysis in GIS to make the final decision. For example, we have seen over here, we have slope, contour, reclassify, and then we get new data, and then from this data we reclassify back to get a new type of data, and then we add more data, and then do some another analysis, get another data, and then do another cost distance analysis, and then get two data, and then from there we combine with another analysis, cost path, and then we got the final decision for our data. So this is the analytical modeling in GIS, the simple words lah. We will not discuss in detail because we will cover in another subject. So I think that's all for our discussion in this topic. So as a conclusion, this chapter discuss on the spatial analysis, the measurement, the queries, reclassification, buffering, map, overlay, spatial interpolation, surface analysis, and network analysis. And then we also discuss a little bit how to combine all the data to get the final decision. So I think that's all from me. Thank you very much. I hope you can understand and enjoy this topic. Thank you very much. Assalamualaikum and see you again.